Thank you very much. It is a pleasure to be here. Having lived in this area for almost a quarter of a century, I got good ties to the valley, and it's always fun to be out among folk here. How many of you spend a fair bit of time on airplanes? Yeah, a fair few of you. I'm sure that when you get on an airplane, what you do is you sit down and you look at the person beside you and say, hey, what I want to do is I want to spend this flight talking to this person. Is that what you do? Yeah, that's not what I do either. I have a special problem in this regard. Turns out that about 1 out of every 100,000 people in the United States can claim to be an astrophysicist. That, combined with the fact that astrophysics is cool, means that if I let the person sitting beside me on the airplane know that I'm an astrophysicist, what I'm going to do with the next 6 hours is answer whatever questions this person has about the wonders of the universe. Such is the nature of life. I was on a plane a while back, and I was talking to a woman, and I forget how it is that the conversation got started. But she announced out of the blue, I'm a psychic. And I said, okay, that's interesting. Tell me, why do you think you're a psychic? And she said, well, the other day I was thinking about my brother, and my brother called. I'm a psychic. I said, okay. Tell me, do you ever think about your brother when he doesn't call? Oh, yeah, all the time. He and I are close. We grew up together. It's wonderful. I said, okay, fine. Does your brother ever call when you weren't thinking about him? Oh, yeah, all the time. It always just makes my day when I get a call out of the blue from my brother. I said, tell me again why it is that you think you're a psychic. Well, the other day I was thinking about my brother and he called. I'm a psychic. Now, at that point, I just kind of let the conversation lapse, because where do you go from there? There was absolutely nothing that I was going to say that was going to disavow her of the notion that she was a psychic. She was making a very fundamental and frankly a very common mistake. She imagined that the fact that she thought she was a psychic made it so. She forgot that there are questions about which our opinions simply do not matter. How many of you know what a wag is? Anybody? That they'll say it out loud, your dog's tail? A wag is a wild-ass guess, is what a wag is. Quite often, the things that we think that we know, we really can't claim to know at all. Really, they're just wags. And wags come in lots of different flavors. One wag, which is kind of the wag that the woman on the plane was taking, is I know it because I know it. Just totally unexamined knowledge. I just know this to be true. Who knows where it comes from? Another wag, also very common, is that I know it because we know it. The group of which I am a part holds this to be true, and therefore I know it. Groupthink is what that's called. Another one, anybody in here like old westerns? Yeah. Okay. You know, in an old western, when the guy comes into town in the wagon and gets out snake oil, you know what snake oil is. Snake oil is that magical elixir that cures all of your ills. And this is the guy who could sell refrigerators to Eskimos. I mean, he's a salesman par excellence. And he sells everybody snake oil. And then you get up the next morning and you've got a gut ache and you've got a headache and you've got an empty wallet, and the guy selling snake oil is long gone. Snake oil is a wag. I know it because somebody told me that it's true. Next one, very common. I know it because I want it to be true. Okay, I really, really want this to be the case. And I so much want this to be the case, I just know that it is. Wishful thinking. Another one, I know it because it worked last year. You know, it's kind of funny. Albert Einstein defined insanity as doing the same thing over and over again and expecting different results. Let's be honest, in today's world, things are changing so rapidly that insanity is doing the same thing over and over again and expecting the same results. Complacency. So here we have it. things that we think that we know quite often are deception, groupthink, snake oil, wishful thinking, complacency. What's the problem? Do any of these have anything whatsoever to do with what really is true? No, they don't. And that's an issue. And it's an issue that everybody in this room should care about. A lot of business leaders in the room, a lot of you own your own business. Lots of studies are done of businesses that succeed. And I was reading kind of an interesting study the other day that was done of businesses that fail. This study reached a very interesting conclusion. 81% of the loss of shareholder value can be traced to a single cause: mismanagement of strategic risk. Now, I'm an astrophysicist, so I had to scratch my head for a minute and figure out what they really meant by mismanagement of strategic risk. But I finally realized what it means. And what it means is they did not realize that the light at the end of the tunnel was in fact the headlight of the oncoming train. That's what mismanagement of strategic risk is. In other words, mismanagement of strategic risk means that they made the mistake of believing their own wags. The road to hell may be paved with good intentions. The road to failure is paved with wags. I learned this the hard way. I was a member of the team that built the first camera that flew on the Hubble Space Telescope. And this is a day that I remember very well. The science team was out on the NASA Causeway. Has anybody here ever seen a shuttle launch? Yeah, it's a spectacular sight. We were out on the NASA Causeway, so we were, I think, about 6 miles away from the launch pad itself, which meant that when the shuttle started to take off, we saw this tremendous bright light from the base. You don't hear it immediately because it takes the sound time to travel. And so in perfect silence, you see this shuttle rising into the sky on top of this column of flame and smoke. And about the time it got to a layer of low clouds and lit them up, the sounds reached us. You don't hear a shuttle launch, you feel it. It just rumbles all the way to your bones. And so that was the experience. Now imagine looking at that and realizing that sitting up in that little rocket on top of that column of fire and smoke is the telescope that you've been working on, the project on which you have staked your entire career. A truly remarkable moment. Hubble was going to be the greatest advance in astronomy since Galileo first pointed a telescope at the heavens. And it didn't work out that way. Because when the first images started coming in, and I actually had the dubious distinction of being the guy that was sitting there in front of a computer console with the television cameras looking over my back when the very first image came in from Hubble, and we looked at it and we said, whoops. You know that you've made the big time if you go to the movies to see a Leslie Nielsen film, and you see Leslie Nielsen sitting here in the Blue Note Cafe, and on the wall of the Blue Note Cafe, next to the Titanic and the Hindenburg and the Etzel, there it is, the Hubble Space Telescope. Okay. You didn't even have to go to the movies. Jay Leno latched onto this thing. He made Hubble into a verb. If you screwed something up by the numbers, you Hubbled it. That's what it meant. In fact, night after night, this was a joke from right around Thanksgiving. What sound does a space turkey make? Hubble, hubble, hubble. Not fun. So the question is, what happened? How is it that you go from being the jewel in the crown of NASA science to being the butt of jokes on late night television? How do you make that transition? Now, there are technical answers to that question. You know, I could spend all afternoon talking about the technical side of this. But what it really boils down to is the Hubble project fell victim to its own wags. Imagine the situation. At the time that they were making the mirror that flew on Hubble, this had to be the best mirror that was ever manufactured. They were over budget, They were behind schedule. NASA was breathing down their backs. Congress was breathing down NASA's back. Everybody was pointing fingers at everybody else. Everybody was involved in a big CYA activity. The last thing that anybody wanted was to hear that there was a problem. One morning, a couple of technicians made a very, very simple, very, very small mistake, and nobody noticed. That mistake started to become obvious, and people still refused to notice. People rationalized it away. They so much wanted it to all be okay that they chose to believe that it was all okay. So in that moment of intense pressure, it created a blind spot. They settled for a wag, and the rest, as they say, is history. They took their eye off the prize. How can that happen? If it's so obvious that wags are a problem, how is it that we give them that kind of power? And the answer is literally, it's what your brain's programmed to do. Right? Think about it. If there's an idea that you care about, just whatever idea, you can think of an idea if you want to. What you naturally do is you go and find other people who share that idea. And you talk to them about it. Say, boy, isn't this a grand idea? You know, you read books, you read articles, you find people who say, yeah, this is how it is. Go on the web, find people, yeah, this is how it is. That's what we naturally do. An example of this, I'm an astrophysicist, and so, again, when people find out I'm an astrophysicist, one of the first 2 or 3 questions that they ask is, are there, in fact, space aliens? Okay. A lot of people out there firmly believe that there are space aliens and they abduct us and they take us off to their spaceships and they do all sorts of things. If you believe that space aliens take us away, what do? You go to your computer, you pull up a search engine, you type in true stories of alien abductions, and you get page after page after page of sites that will tell you all about space alien abductions, how they do it, about the government cover-ups that try to hide it. It's all there. And so you say, see, I knew it all the time. There are space alien abductions. It's what we do naturally. In fact, psychologists have a fancy term for this. They call it confirmation bias. When you have an idea, you look for people who agree with you. It's the way your brain's wired. The problem is that confirmation bias is exactly where wags come from in the first place. Confirmation bias is how you feed a wag. So if you want to not fall prey to wags, if you want to not fall prey to the error that causes 80% of business failure, you've got to do better. You have to find some way to do something other than what your brain naturally wants to do. And here it is. If you're going to take away a single idea from the presentation today, if you're looking for a single thing to write down, this is it. Knowing something does not mean that you have gone out and looked for reasons to believe it. Knowing something means that you have done your best to show that it's wrong, but so far have failed. Let that sink in for a minute. Think about how that works. If I have an idea that's valid, a good idea, a solid idea, does it have anything to fear from that? No. In fact, if I have a good, solid idea, then challenge will only make it stronger. Because the more you challenge it, the more confidence you will have that that's actually the way the world is. On the other hand, if I have a weak idea, is that an idea that I really want to hold on to? Yeah. A weak idea, an idea that can't stand that kind of challenge, was never anything but a wag to begin with. That's an idea that's going to take you down with it. So there it is. Here's the punchline. We know things not by showing that they're correct. We know things by doing the best we can to show that they're wrong and failing. If this is how we do it, why don't we just all do this naturally? Are any of you in the room, a bunch of you in the room are parents, doubtless. Is there anybody in the room who is a parent who has not at some point or other had the experience of having their kids go off and do something stupid because their friends did it? And you ask the question, okay, if your friends jumped off a bridge, would you do it too? Yeah. The answer is yes, they would. Because we're lemmings. We are the go-along to get-along species. And there's a reason for that. It's bred into you. Think about it. You are at the end of a long line of ancestors who would do anything, say anything, believe anything if that meant they got to stay a part of their group. Because if they got kicked out of their group, no food, no social group, certainly no chance to reproduce. If they didn't do anything, say anything, believe anything to remain a part of their group, guess what? You wouldn't be here. It is bred into you to buy into WAGs, groupthink. So what do we have to do? Is it going to be easy to fix this? No. The only way that you're going to get past this is if you take that standard of knowledge, that knowing means that you have challenged something, trying to show that it's wrong, but have so far failed, and turn that into a habit of mind. You have to reach the point where you cannot even look at an idea without immediately asking yourself, how might I know it if this idea is wrong? And if you just look at every idea like that, get into that habit, then you'll see the WAGs that would take you down. Which brings us to this concept, leadership. Everybody talks about leadership. What's the number one task that a leader has to do? What's their first job? It's to lead. It's to look at the future. A leader's job is to be the person who can see far enough down the road to make the decisions today that will put your business where you want it to be next year, or the year after, or the year after that. The quality of that leadership, can you make those decisions well if your knowledge is wrong? No, you can't do it. The quality of your leadership depends directly on the quality of your knowledge. Here's the bad news. If your business fails, there is an 80% chance that the reason it failed is because you did not see something that you should have seen coming. It's kind of bad news. Here's the good news. I just told you how not to make that mistake. This is hard. Killing WAGs is not easy. But can you afford not to do it? Turns out the good news only gets better from here. Leader has to see things coming, avoid those mistakes. The other thing a leader has to do, though, is a leader has to find opportunity. A leader has to find the directions that they can take their company, their corporation, their organization that will open up new vistas for them. Think about this. If there's something that everybody knows, and you're the one who figures out that it's not true, that's power. Francis Bacon is the one who first said that knowledge is power. And certainly in today's world, knowledge is power. You want opportunity? You want to know a direction that you can go that's going to put you out in front of everybody else? Here it is. When you kill a WAG, you create opportunity. Now, looking for examples of this kind of thing, it's actually hard not to find them. This is another challenge for you. Now that we've talked about this, if you want to see it in action, open any business page, open any business magazine, find an article about some company that had horrible problems, and if you look at it, what you will see is that somewhere in there was a WAG that they bought into. Now, this is just too good an example not to run with. The Twinkie. We all heard about the oh, Hostess, where am I going to get my Twinkies? The Twinkie actually, this I didn't know until recently, the Twinkie was invented in 1930. 1930 was the year after the stock market crash. And the idea of the Twinkie, it was very innovative for its time. The idea of the Twinkie was that it was cheap, it had a lot of calories, it was not really perishable. You know, we've all heard the joke that when archaeologists come along in 5,000 years and dig things up, it'll all be gone except the Twinkies. It was a great innovation. Fast forward the clock by roughly 50 years to 1977, the year after I graduated from high school. It was the year that a little startup company called Apple Computers came out with a little device that was called the Apple IIe. Now, the Apple IIe had a couple of floppy drives, for those who still remember what floppy drives are. I think it maybe had 64K of RAM. You could run Pong on it maybe, and you might be able to write a letter on it, and that was sort of what it was good for. In that same year, the Twinkie was still the Twinkie, and Hostess, or its predecessor, was one of the biggest food conglomerates in the world. 1977. Now let's forward the clock to 2012. 2012, Apple is selling desktop computers, laptops, iPads, iPhones, iPods. Apple has become the highest valued corporation on the planet. What happened to Hostess? They went bankrupt. And that was still Hostess's product. It's very fashionable to say that Hostess fell victim to the unions. Hostess didn't fall victim to the unions. Hostess fell victim to their leaders' complacency, their leaders' groupthink, their leaders buying into the idea that this has always worked, so it will continue to work. That's what took down Hostess. In fact, imagine, you might say, well, gee, in computers, there was all this new technology, there's no comparison here, but think about it. It was along about this same time that a little company called Starbucks came along and started changing the way that we do coffee. Can you imagine if the people at Hostess had been challenging their wags? Had they been saying, you know, there is evidence that tastes are changing. There's evidence that people are getting more health conscious. There's evidence that people are getting more interested in kind of designer foods. What if Hostess, with that in mind, challenging their wags, constantly questioning their business plan, had gone to Starbucks and said, you know what, we would love to put together for you a designer line of pastries that you can sell in your shops? If Hostess had done that, then Hostess today wouldn't be bankrupt. If Hostess had done that, we'd all be sitting around with lots of money in the bank because we were so glad that we invested in Hostess way back in 1977 when all they had were Twinkies. But there's another thing. What did Apple have to do to go from the Apple IIe to having all of those other products? There's a word for that. What's that word? Innovation. You hear a lot about innovation. I'm an astrophysicist. I know from innovation. You know, my whole career, frankly, has been about the life cycle of ideas. You know, the old joke, it doesn't take a rocket scientist. I have a t-shirt that I sometimes wear if I'm teaching a college class that says, actually, I am a rocket scientist. Innovation. The first thing that you need to do if you're going to innovate is you've got to find the killer opportunity. You have to find the opportunity, the thing out there that, boy, if I can invent the better mousetrap, if I can solve that problem, then the world will beat a path to my door. Question is, where does that opportunity come from? I just told you. The world will tell you where that opportunity is if only you listen. And the way that you listen is by challenging your wags. The way that you listen is by saying, what if this is wrong? What if this is wrong? What if this is wrong? Trying to show that they are, finding something that everybody thought that they knew that's not true, and there you go. There's the door open for innovation. Next thing you have to do if you're going to innovate. So now you've got your killer opportunity, you want to go do it. I'm sure that what you then do is you come up with one idea and you say, boy, I bet this is going to fix it, and you just run with that idea, right? I sure hope not. The next stage of innovation is you get creative. You know, people very often ask, well, you talk about this very critical kind of thinking. What about creativity? Moving forward is, in fact, a balance between creativity and challenging ideas to see which ones hold water. In this case, again, I was part of the team that fixed the Hubble Space Telescope. After the problems with Hubble were discovered, people started scratching their heads. Lots of good people started scratching their heads and asking, what can we do about this? And over the couple of months that followed, there were something like 36 different ideas that people came up with for how to fix Hubble. Good people. And they worked them up, they ran the numbers, they looked at feasibility, 36 different ideas that, hey, we can do this and fix Hubble. If somebody had just taken the first one of those and run with it, then this story would have a very bad ending. Because what happened then was all of those people got together, and each person got up there and presented his or her idea on how to fix Hubble, and everybody else in the room tried to tear it down. They put this standard of knowledge into practice. Okay, here's an idea. That sounds like an interesting idea. Pretty interesting wag to me. Now let's attack it. Let's do everything we can to tear it down. Over that process, 36 ideas of how to fix Hubble became 36 minus 1 bad ideas and 1 good one. The second stage of innovation, get creative. The third stage of innovation, take your ideas and challenge them. Here's just a fun cartoon that's sort of, you know, a way to fix Hubble. Here you've got an astronaut with a tube of Visine, and here you've got an astronaut with a lens cloth, and here you've got an astronaut with a contact lens getting ready to put it on. Some of the ideas that they came up with to try to fix Hubble were real doozies. You know, they had ideas where an astronaut was going to crawl down inside the front of the telescope and all sorts of things. Challenge and confront. So there you go. There's a recipe for putting your company out ahead of the competition in a few years' time. Kill your wags, get as creative as you can possibly get, and then kill all of those ideas that you can and see which ones survive. Put yourself in that room. Get this inside your head. You've just spent the last couple of months thinking about a way to repair the biggest big science mission ever. You've worked it out. You've convinced yourself that it'll work. You're going to be the hero. You were vested in this idea. And then you go into a room and you present it. And what does everybody in the room immediately start doing? Tearing it down. Do you suppose that that is a comfortable place to be? No, I can tell you from experience, that is not a comfortable place to be. This is hard. Which brings us to another concept that people talk about, teamwork. If you're testing wags, you know, that people talk about a team working together. From my perspective, the value of teamwork is less in the unity of the people on the team than it is in the diversity of the people on the team. Because if you've got a team, everybody on the team brings with them a difference in background, a difference in expertise, a difference in experience, a difference in perspective. So if you're trying to attack a wag, the thing that a team gets you is lots of vantage points from which to see the idea's problems. That's what a team's for, but it's hard. You know, if you think about it, teamwork activities more often than not are, you know, you go to these workshops and they do things like have you blindfolded stand there and fall over backwards and your team member catches you and this is team building. Those are all about building trust. And for me, those are all about building enough trust that you can sit down with your team and have them critique your brilliant ideas and actually trust them enough to let them do it. Yeah, let's face it. If you just heard me talk and you said, boy, good thing to do is go start killing people's wags, and I'm going to make the world a better place. And I'm going to make the world a better place by going back to my place of business, and I'm going to walk in and I'm going to start telling everybody how wrong they are. Have that in mind. I think it probably looks something like this. You know, here's the guy the guy over on the left is the one who clearly just came in and said, I'm the wag killer, I'm here to help. The guy pointing his finger is about ready to tear him a new one. The woman back there is staring daggers into him. I mean, she is visualizing this guy boiling in a vat of oil. And the guy over on the right, he's got a headache and he just wants it to all be over so he can go home. This doesn't work. If you're going to do this, you have to build the team to be able to do it. Now, there's some rules for that. If you've got an idea, and I don't like that idea, am I going to get anywhere if I come at you and say, you're a real idiot to have that idea? Probably not. On the other hand, if I say, that is an interesting idea, I see where it came from, but I see the following problems, that's now a different conversation. First rule, when you're killing wags as a member of a team, don't attack the person, confront the idea, and remember that. Because remember, right now it's you confronting somebody else's idea. Tomorrow it's going to be them confronting yours. So, you know, this goes both ways. If you're leading a team, then you have other responsibilities because you're the one who's got to make it happen. And there's some rules for that too. First thing is you've got to start with yourself. You know, there's the Bible verse that says you have to see the plank in your own eye before you can remove the speck in your brother's. It's the same thing here. Start with yourself. And this is a challenge I'm going to give you. You know, I gave you the practical, this is the takeaway message. Now I'm a university professor. I have to assign homework. Here's your homework. Leave here, and when you've got a little time and it's quiet and you can think to yourself, what are the fundamental assumptions? What are the fundamental ideas that underlie my business plan? And after you have those, think about how you know those things. And I would bet you a good bottle of scotch that you'll find that several of the items on that list fall into the category of I just know it, it's groupthink, somebody told me it's true, I want it to be true, this worked last year, I guess it'll still work this year. Next thing you do is you start looking for reasons to doubt those ideas. Start actively trying to show that they're wrong. If you do this, I will bet you that several people in this room will have a different business plan in a year than they have today. Pure and simple. You have to start with yourself and you have to lead by example. If you're leading a team, it can't be you coming in and saying, I'm going to challenge all of your guys' ideas. The place that you have to start is you have to come in and say, here is my idea, challenge it. Finally, what you have to do is you have to create the culture. Because let's face it, this is a hard culture we're talking about. A culture in which the worst thing you can be is a yes man. A culture where you realize that the best way to pursue your personal best interest is by bringing problems to light, knowing that they're not going to shoot the messenger. Start with yourself, lead by example, create the culture. And over time, you can build a team that will let you catch your wags, find opportunity. Now, I am very pleased to say that a lot of stories have happy endings. The Hubble Space Telescope, I am pleased to say, had a very happy ending. This is the night that they pulled the old camera out of the Hubble Space Telescope and put the new camera in that was going to repair it. Kind of very briefly, the way that they fixed Hubble was not by fixing the telescope, but by making different instruments to use it. It's a little bit like, you know, when I take off my eyeglasses. My eyeglasses have an error in them, and my eyes have an error in them. But it turns out that the error in my eyes exactly cancels the error in my eyeglasses. So when I put the two together, I see well. In the case of Hubble, you can't change the eyeglasses. The telescope is the telescope. But what you can do is change the eyes. So it was a matter of building instruments that had the same error that the telescope did, except they had it in reverse. So the two canceled out. It's really as simple as that. I remember this night well. This was the night that they took out the old camera. They put in the new camera. I actually was in the operations area at the Goddard Space Flight Center this night. I was there because my job was, as soon as they installed the new camera, I ran tests on it to be sure that, you know, basically it was operating okay, so that if there were problems, there was something that could be done about it. And it was an extraordinary night, because here I was, big screen television here, watching the astronauts put this camera on which I had been a part in the telescope, hearing the communication back and forth. On my computer console, the camera comes alive. And in the midst of all of this, here I am running tests on it. I actually took a moment and I stopped and I just appreciated the moment, because it was like being in the middle of a science fiction film. I just don't know how else to describe it. And it worked. We fixed Hubble. So now, instead of being known for disaster, Hubble is being known for its extraordinary vistas of the heavens. Pictures like this. This is an image of a thing called the Trifid Nebula. This is an image that I took with the WIFPIC 2. It's a region about 7,000 light years away. It's a place where stars and planetary systems are being born. Turns out, in fact, that if you could go back to the birth of our own sun and solar system, this is the kind of environment you'd see. A remarkable picture. And a remarkable picture that if you look at for a second, you say, there's something missing. What happened here? You know, that lower left-hand corner. For some reason, your field of view looks a little bit like a profile of a stealth bomber. What's going on? There are lots of technical answers to that question as well. But the real answer to that question is that's where we killed a wag. Go back to that setting. The biggest thing in space science ever has turned out to be a turkey. Everybody is watching. You talk about living in a fishbowl. This was living in a fishbowl. Everybody's breathing down everybody's back. Everybody's under scrutiny. Nobody wants to be the one who says there's a problem. And so what do? They start trying to ignore problems because nobody wants to be the one that stands up and says, here's the problem. It's the same kind of pressure, frankly, that caused the problem with Hubble in the first place. It turns out, and this is one of the things that I am proudest of in my career, there were several of us on the science team that realized there was a problem, realized that in building the new camera, they were doing something that could very well cause the camera not to work. And we said, there's a problem here, you've got to fix it. Do you suppose that the project said, well, thank you very much for pointing that out? No, because nobody wanted to deal with it. They just wanted to keep doing what they were doing. It became kind of a nasty fight, to be perfectly honest about it. And I remember one morning, I think it was a Thursday morning, it was about 10 in the morning as I recall, at the Jet Propulsion Lab, and there was a shootout. The science team was sitting on one side of the table, the project personnel were on the other side of the table, and going back and forth, and there was a guy from NASA headquarters who had come in to adjudicate this. And so he sat there and listened, and he asked the project to present what they had to present, and he asked us to present what we had to present. And then he turned to us and said, do you think there's a problem? We said, yep. Are you confident enough that there is a problem that you would be willing to give up part of the capability of your instrument to fix it? And it took us about half a second to say, yeah, we'd be happy to do that. That little notch in the corner of the field of view is what was lost. What was kept was the ability of the Hubble Space Telescope to take images from orbit that showed 100 times more detail than you could see from the ground. In other words, what we did is we said, here's a WAG, it matters, we know what really matters, and we are going to keep our eyes on the prize. Be willing to give something up to keep what it is that we really had to have. I've done a bad thing to you guys. I've done a horrible thing to you guys because I just told you how it works. I just told you that if you run into failure, there's a pretty good likelihood it's because you didn't see something that you should have seen. And not only that, I told you what you ought to be doing so that you won't miss it. I even told you that if you do that, it'll open the door to new opportunities. So, you know, quote from Spider-Man, Uncle Ben to Peter Parker, with great power comes great responsibility. Sorry, guys, I just laid that cloak of power on you and you've got to live with it. Something goes wrong from here, then don't look at me. You know, you can't plead ignorance. I remember the first time that I looked through a telescope. It was a little dime store telescope in a friend's backyard. Looking at Saturn and its rings, I can still see it in my mind's eye like it was yesterday. In that moment, I fell in love with astronomy. But it's a long path from looking at Saturn in a little backyard telescope to finding yourself at a ceremony where they're unveiling a series of stamps with your work on it. You don't get from one place to the other by settling for wishful thinking, by settling for complacency, by buying into groupthink, by settling for snake oil. The way that you get from one place to another is by refusing to settle for less. I am happy that in my life I didn't, and there is absolutely no reason that you should either. Thank you very much. Thank you. And I'd be happy to take a question or two if there's time for that. Yeah.
I've always been intrigued by that photograph, and I believe it to be an image. And as I understand it, that's really not real in the sense of the way we would show an image. What did you do to actually get that, or who decided on that particular image?
I did.
Did you look at different color ranges for the different types?
Well, the way that if you really want the details on this, and this actually becomes a talk in its own right because it goes into the way that we see things and how we see patterns and all of that kind of stuff. What makes that image beautiful is the same thing that makes it scientifically interesting. The way that image was made is there was a picture taken of light coming from hydrogen atoms. There was a picture taken of light coming from sulfur atoms that had a single electron stripped away from them. There was a picture taken of light coming from oxygen atoms that had 2 electrons stripped away from them. And what we did is we took those and we put them together, putting one of those on green, one of those on red, one of those on blue, and that was the result. And so, no, it's not a true color image, but in fact the colors in there are telling you about the physics of what's going on. Having said that, though, it's kind of funny because if you look at this in a telescope, this is closer to what your eye would actually see than a normal color picture of this is. It's kind of funny. When you take a color picture, it turns out that the red sensitive part of the film is sensitive to things that are redder than your eye can see. And there's a really, really bright emission line out in the red that just completely swamps everything out. So when you look at a picture of a nebula, you usually see it as red, and then you look at it through a telescope and it looks green, and you say, what's going on? That's what's going on. So the irony is, no, this is not a true color picture, and yet it's closer to true color than a color picture.
Wow.
Other questions? Yeah.
What did you give up? Was that a defect in the lens, or was that processing space?
Very, very briefly, originally the wide field planetary camera had 2 modes. It had, this is, if you look at it, you can kind of see that this is made up of 4 different pictures. I don't know if you can see the laser or not, but there's one in the upper left, one in the lower left, one in the lower right, and then there's a little one in the upper right. Is what went together. Originally, the camera had 4 cameras that were wide field cameras that would have made that a square, and 4 cameras that were small field cameras that would have made another square the size of the little one, 4 of the little ones that would have had higher resolution. And so what they did is they threw away half the cameras. And so we kept 3 that had the big field and 1 that had the little field, is technically what happened. So we gave up half the cameras. That's what we kept. And I'm sure glad that we did, because it turns out in retrospect that the fix that we put into that to allow us to adjust things on orbit had to be used. But had we not done that, Hubble would not have been able to do what it since did. Other questions? Yeah.
You know, I hear a saying a lot of the times, and I've always been wanting to ask this. There's a saying that says that we are made of the stuff of stars.
Yep.
And with your presentation, I've always wanted to know, is that a wag, or is it something that you feel that is true?
It is. You ask an interesting question there, and I'm gonna step back a little bit in my answer to it. I have been talking about the ideas behind this for years and years. It's just that usually I've talked to roomfuls of students about this, and kind of why I'm doing what I'm doing now is that I came to realize that the audience for this was an awful lot broader than students in an astronomy class. I would always say to students that anytime you're sitting in a class, you have a right to stop the person at the front of the class and say, "How do you know that?" And they had better be able to give you an answer. And the answer that they had better be able to give you is an answer along the lines of, because we have tried to show that it's wrong in all of these ways and have failed. Okay? In this case, we are stardust. You are in fact made of atoms that were born in supernova explosions, that were spread through the universe, that crystallized into dust, that were part of an interstellar cloud that collapsed to become the solar system that became incorporated in Earth. How do I know that? I know that because our understanding of the expansion of the universe predicts that when the universe was young, it should have all been hydrogen and helium. Now, you could show that that's wrong by looking at galaxies that are very far away and hence far back in time and saying, I'm going to show that's wrong by showing those galaxies have all sorts of stuff other than hydrogen and helium. Well, that turns out not to be wrong. Then you say, well, my idea is that you make new chemical elements inside of stars and they explode. And I'm going to prove that wrong by going and looking at stars that explode and showing that there are no new chemical elements in them. And so go and you look. And you fail to prove that one wrong too, that in fact you see all of these new chemical elements. And then you say, I'm going to prove that that's wrong because I'm going to show that the pattern of chemical elements that we find in us is different than the pattern of chemical elements that come out of these stars. I'm going to show that that's wrong. And you go and you try to do it. And again, you fail miserably. But if you look at the pattern of the abundances of elements in your body, pick up a handful of dirt, you can see in that the fingerprint of the formation of those elements in stars. This is a thing that people tend to get wrong. These scientists always trying to prove things. That's not the way that it works. Everybody in here has heard of the Big Bang, right? Do you know where the Big Bang got its name?
Television show?
No, not, Yeah, I love the Big Bang Theory. The Big Bang Theory is sort of centered around the California Institute of Technology, where I spent a bunch of years. And I don't know how other people find the Big Bang amusing, because frankly, all of the best jokes on the Big Bang are insider jokes. There's a scene on the Big Bang where Sheldon is standing there. It's a paintball fight. And he stands up and says, "Geology is not a real science," and he gets plastered with paintballs. That is the funniest single moment in the entire show. But anyway, the Big Bang, the idea of the Big Bang started when a guy by the name of Edwin Hubble, in fact, the namesake of the telescope, discovered that the farther away from us a galaxy is, the faster away from us it's moving. And if you think about that for a minute, you say, gee, that says that the universe is expanding. If you go forward in time, it's getting bigger. If you go backward in time, it says that things get smaller and smaller. A guy by the name of Fred Hoyle looked at that idea, and he said, "That's the most ridiculous thing I have ever heard. That is just nonsense. You idiots think that the whole universe began in a Big Bang or something." And the name stuck. The Big Bang actually started out as a pejorative term for the idea that the universe had that origin. And now I can stand up here today and say it is a fact that the universe began in a Big Bang. The reason I can say that is that for roughly the last 90 years, thousands of very, very smart people have done everything that they can think of to show that that idea is wrong and have failed. It's kind of interesting. It flips things on its head, and there are all sorts of aspects of this that we can talk about. One fun thing about this is it never stops. And this is actually important for you guys as well. It's not like you go out and you slay your wags and say, okay, now I'm done, it's all over. It doesn't work that way. I can go out tomorrow if I can think of a new way to challenge it and try to show that the Big Bang is wrong. This never ends. You never reach the point that you say, I'm absolutely certain. You always question. You always challenge. Which is, again, why it just has to become a habit of mind. It has to become part of the way that you interact with the world. Other questions? Yeah?
Why did you call it an Eagle Nebula, and how do you determine its chemical composition?
Eagle Nebula. It turns out that when you look at this nebula through a small telescope, it has a couple of wing-like structures on it. These things sort of look like a talon. And so early on, you tend to look at things and say, that kind of looks like such and such. You know, I worked on the Crab Nebula, for example, that Lord Russell thought looked like a crab. So that's where the name originally came from. The way that I can talk about what it's made of, it turns out that every kind of atom has its own spectral fingerprint. You know, neon lights? You see different neon lights, and depending on exactly, there are neon lights and there are helium lights and there are, mercury lights and all of this. There are low pressure sodium lights. When you have a gas that you excite and cause to glow like that, it doesn't give out light at all different wavelengths, all different colors. Rather, it gives out light at a few very specific wavelengths, a few very specific colors. And so by looking at the light from something and looking at the strength of those different emission lines, they're called, then you can figure out things like how hot is it, what's its density, what's it made of. Other questions? Yeah.
So if you're continually looking at your wags and trying to prove them to be false, at what point do you decide that something should be successful?
At what point are you done?
Well, I mean, you could be stuck in a perpetual cycle of saying that's not going to work, that's not going to work, that's not going to work, and you're not going to get anywhere.
You just hit the nail on the head. Another aspect of this is courage, because this process never ends. You should always be challenged, which means that you never reach the point that you say, I'm 100% certain. Because guess what? If I say, I'm 100% certain, what I just said is that nothing could ever make me change my mind. I'm 100% certain. If nothing could ever make you change your mind, is there anything that could cause you to discover that you're wrong? If nothing could ever cause you to discover that you're wrong, is there any way you can actually claim to be right? It never ends. The hard reality is that logically, like 1 + 1 = 2 logically, we can never have absolute certainty. That as soon as you say, I am certain, what you've said is that all I can ever have is a wag. Knowledge and certainty are the opposite of each other. What that means is that when you act, it requires courage. Courage to act understanding that there's uncertainty. Courage to act even as you continue to look for flaws in what it is that you're thinking. I never promised that I was going to come in here and make it easy for you. But that's the reality. If you think about it, though, now at least you know that you're acting in the face of uncertainty. Because it's a darn sight better to know that you're acting in the face of uncertainty than it is to be unknowingly acting in the name of delusion. And those are your options. Other questions? Yeah.
I guess there can be a huge discussion then on if religion is a wag or if faith is a different prospect when it comes to scientific discoveries and the origin of man and so forth. What's your opinion on that?
I'll tell you what, if you want to buy a good 17-year-old bottle of the Macallan, then we'll find an opportunity some night to sit down and put it away and have that conversation.
All right. One last question. If there's any out there. Last opportunity.
You talk with fact. You know, I can say this as fact, but you're talking with fact known now that this is like current fact based on the inability to disprove it. That would be a definition.
Well, let me ask you a question. Do you accept that it is a fact that Earth revolves around the sun?
I do.
Okay. A few hundred years ago, had you said that, they may well have burned you at the stake for having done so. That's what happened to Giordano Bruno, for example. Really, what the statement that Earth revolves around the sun is a theory that is very, very well tested. I could spend 3 days telling you all of the different ways you can test the theory that Earth revolves around the sun, all of the ways that you could have discovered that it's wrong. And eventually what happens, you know, another one, force equals mass times acceleration. If I hold up a pin and drop it, it'll fall to the ground. All of these things we take as facts. Again, really what they are ideas that have survived this kind of regimen of test. Something might start out as a wag, evolve to become hypothesis, be tested until you start to say, yeah, maybe that's something I can hang on to. Eventually, some of these things get to the point of just saying, yeah, it's a fact. But you never go beyond the ability to go out there and test it again just one more time. All right? Thank you very much. It was a pleasure.